All right, so for today's class, we're doing finding the LCD within rational expressions. So I'm going to go over a few practice problems to give you guys some perspective on this. Notice at the top here, I have the steps written out. So we'll revisit those so that way you know how to go about doing these problems. We're going to start out with number 19. Number 19 is a bit of a tricky one. So we're going to try number 19. And I'm just going to copy it down. So I got 4 over 21x squared. And then I have x over 3x squared minus 15x. Okay, so now we want to find the lowest common denominator. Now ultimately, that we're just focusing on these denominators, which is down here. All right, so now our first step when we're doing this is we want to factor each denominator individually. So we're looking for, if we have constant terms, we're looking for prime factors. If we got polynomials, look for the GCF. If we got quadratics, we want to factor our quadratics. Let's start with our first one here. We have 21x squared. So my goal here is I want to prime factor 21. Let's see, what can I do here? What times itself will equal 21? I've got 3 and 7. So I can go 3 times 7 times x squared. So all I do is I broke it up a bit here. I'm going to draw a line here. I like to do that to keep everything separated. I can't break this down any further. If I wanted to, I could break this down to x times x, but I don't need to do that. Now, the next one I'm going to look at is my next denominator here, 3x squared minus 15x. So let's take a look here. I got myself a polynomial. So I'm going to look for the GCF first. Now I'm looking here, and I notice I've got 3 and 15. Greatest common factor between those is 3. So isolate 3. And I also notice that each term also includes x. So I'm going to divide by 3x, which leaves me with x minus 5. So I could break this down further. I'm going to do that. 3 times x minus 5. So all I did was I just kind of separated everything. Now my next step here, I'm going to break it down. So I'm going to go right out what I've got. I'll start out with that 3 times 7 times x squared. I like to stack them. That's kind of the approach I take here. So now the next approach I want to take is I want to take my my second denominator's factors. I'm going to put them right below. And I want to look for factors that they share. So if I look here, I notice that this one has 3, and this one has 3 as well. So I'm going to put the 3 right beneath it, just like that. I'm noticing that, let's see, they also share x squared and x, so they share an x. Now, a lot of people would jump to the x minus 5. That's an entirely other factor. You'll notice that within it, there's subtraction going on. This is its own factor, so I'm just concentrating on the x's. So beneath that, I'm going to put x. So again, the x's line up. I'm noticing I've got a 7 up top here. Nothing goes with the 7. And I got x minus 5, so nothing goes with that. And now here's the key. This is the way I like to approach it. I notice that they share a 3, so I only need to use that 3 once. 7's on its own. X squared, I'm going to go with the highest exponent when they share that variable. And I've got times x minus 5. So essentially, this is my LCD. All I need to do is multiply it out. 3 times 7 would give me 21, times x squared gives me 21x squared. And then times x minus 5. And I can leave it just like this for now. This would be my lowest common denominator between, oops, wrong tool, that's okay. 21x squared and 3x squared minus 15x. The lowest common denominator is going to be 21x squared times x minus 5. These aren't super easy. I want you to think that I'm trying to say that this is really easy. It isn't. But you just want to go through your steps. And if you go through your steps, it's not as difficult as it seems. So the next one I'm going to try here is number 20. I saw a lot of mistakes with number 20 when I was initially doing this. When, people were trying it. So let's go over number 20 so you can get an idea. So number 20, you'll notice we have 5x plus 2 over 4x squared minus 1. I've got 3 over x, and then I've got 9x times 2x plus 1. So I've got 3 denominators going on here. I got to find the LCD between three denominators. All right, so what some people were doing initially was they're trying to break this up into pieces, saying like 4 times x squared times negative 1. But that's not what's going on here. I got 4x squared subtracting 1. There aren't factors going on here. I mean, if I really wanted to, I guess I could break up 4 times x squared. But what I'm looking at here is a polynomial. This isn't a constant term. I'm looking at a polynomial. So since I have 4x squared minus 1, I got a couple approaches I could take here. I could identify this as a difference of squares. Difference of two squares, factor it out from there. Some people are more comfortable approaching it this way as a quadratic. They'll do, okay, 4x squared. I don't have anything in the middle here, so I'm just going to put minus 0x minus 1. And then they use this opportunity to use the box method, which, I like the box method. I think it's cool. So I'm going to identify a times c, which would be 4 times 1, which would give 4 times negative 1 gives me negative 4. And then b equals 0. So I want two factors of negative 4 that when I add them are going to add up to 0, which would give me negative 2 and positive 2. So then, again, a lot of people, they like the box method, so I'm going to rock it out. I would get, break it up, 4x squared, negative 2x, positive 2x, and then negative 1. And then I factor going across, and I factor going down. So let's start by going across. 4x squared and negative 2x, they share 2x as a common factor. 2x minus 1, they share 1 as a common factor. 4x squared and 2x, again, they share 2x as a common factor. Negative 2x minus 1, they share negative 1. I remember that's negative because our first term is negative. So if I want to break this up, I get 2x minus 1, 2x plus 1. So I've factored 4x squared minus 1. That's how you want to approach the polynomials. Make sure you're approaching it like that. So that's my first denominator here. Again, I'm going to draw the lines just to keep things separate. It's always good to do that. Sometimes people need that differentiation, just to keep things separate. Now right here, 3 over x, I can't do anything with x. X is just all by itself. I can't do anything with that. Just going to leave it. And then 2x plus 1, I can't really factor that. The only thing I can really factor out of that is 1. So I'm just going to leave it as it is. And this is where I come back to the stacking. I like doing it this way. Some people like just to kind of go through and then see, write it out, but I like to stack it. So I'm going to go with 2x minus 1 times 2x plus 1. Now I have this x all alone here. I do not want to line it up with either of these x's. A lot of people would do that, but remember, we're looking at the factors as a whole. This expression here is considered a factor. This is considered a factor too. So I can't just isolate the x's within there. So this x here, I'm going to just write it down below because it has nothing it can go with. And then my last one here, 2x plus 1. That happens here. So that means I just have to use that 2x plus 1 once. So what does this become for my LCD? I'm going to rewrite it as 2x minus 1 times 2x plus 1 times x. And I'm just going to rearrange the order here, put x on the outside, 2x minus 1, 2x plus 1. And I have my LCD here. So again, remember these steps in doing this. 1, factor each denominator, and that's individually. Look for constant terms, Any constant terms would be like if you had like 18, like if you had like, as I said here, like say you had 2x, or actually 2x is a bad one. Say I had 5x over 18. Then 18 would be a constant term, and that's how I would factor that out. And, oh boy, that should be 3. Good catch. That's why we do this. And then polynomials. If it takes a form like this, look for a greatest common factor. Chances are you're going to isolate a greatest common factor. And then, if it's a quadratic, remember, you want to break it up into polynomials here. In this case, we have 2 binomials. And that'll ultimately help you find this LCD. So hopefully this helps you in finding the lowest common denominator. It can be a bit tricky, but if you break it down to these steps, then hopefully it can help you get through this a little bit easier.